This video is for your notes on inequalities. This is part 1 of 2 videos, which covers pages 117 and 118. You'll need a pencil. A mathematical sentence that compares 2 equivalent expressions. If it's equivalent, they'll use the equal sign. So if you see an equal sign and the 2 expressions on either side, we have an equation. A mathematical sentence that compares 2 unequal expressions will use a greater than, less than, greater than or equal to, or less than or equal to symbol. In this case, we have a greater than, which means the left expression is greater than or bigger than the right side of the inequality. So it's saying that one expression is bigger than the other expressions, or it's not equal. The in is a prefix that means not. So this is how you remember the difference between an equation and an inequality. We have the greater than symbol. We have the less than symbol. And if you merge the greater than symbol with the equal sign, then you can put those together to make the greater than or equal to, which means it can be bigger or equal. If you merge the less than and equal signs, then you can put those together to make the less than or equal to symbol. There are a lot of helpful hints when graphing inequalities. First, if you cannot be equal to the number, we're going to have an open circle, which means there is not a solution at the point that we have the circle. We are going to use the less than or greater than symbols to show that it can't be equal. If it can be equal to the number that we put our circle, then there is a solution. That's where we're going to fill it in, and it's called a closed circle. We are going to be using the less than or equal to or greater than or equal to show that it can be equal to that number. So if we have that equal to sign underneath the inequality symbol, it can be equal. You can flip the inequality if you don't read the x first. So here it's saying that the 5 is smaller and the x is bigger. So you're saying the same thing if you flip the x to the left side, if you flip the inequality symbol as well. So we still want to say that x is bigger and see that 5 is smaller. So if you flip the order because you want to see x first, then you need to make sure that you're flipping that sign as well. Which way does the arrow go? You can always try a number that is on one side of the dot, put it into the inequality, and see if it works. If it does work and it makes a true statement, then that is the side with the arrow. If it does not work or it makes a false statement, then the opposite side is going to have the arrow. So if a number to the left works, it'll go to the left. If it does not work on the left side, the arrow will turn to the right, and vice versa. If x is on the left of the inequality, then the inequality symbol is already pointing in the correct direction. When we graph inequalities, we're trying to graph every single possible solution for our variable. And we're trying to figure out what numbers, in the case of x is greater than 2, all of the numbers that are greater than or bigger than 2. So, what are some solutions for x? We first want to start with 2, see if 2 works. Then try a number that is smaller and try a number that is bigger. So if I'm looking at this, I'm trying to see if 1 is bigger than 2. And I see 2 is actually bigger. And the bigger side is not pointing to the 2, so this is not a solution. Is 2 bigger than itself? Well, 2 and 2 both have the biggest value, so they're actually equal. So this is not a solution either. 3 is bigger than 2, and we see that the bigger side of the inequality is touching that, so we see that 3 is a solution. So 3 is a solution, but 1 and 2 are not solutions, because we're looking for what is bigger than 2. Since we're comparing it to 2, this is where the circle will go. And if we look at 1, 1 was not a solution, 2 was not a solution, and 3 was a solution. So since 2 is not a solution, we're not going to fill that in. And everything to the left isn't a solution, but everything to the right, or on the side that 3 is going to be a solution, because all of those are bigger than 2. So we see everything over here that's not part of the inequality and not part of the graph. All of these integers are not solutions. 0 is smaller than 2. It's not bigger. If it was, it would be on the side of the 3. So 3 is bigger than 2, 4 is bigger than 2, 5 is bigger than 2. So everything that's part of the graph is going to be a solution. So 4 and 5 are solutions, but we also have bigger numbers like 12. We have 53 is bigger than 2. 104 is bigger than 2, and then there's a bunch of fraction and decimal. Now we're going to graph m is less than or equal to -1. So we're comparing it to -1. That's the first thing that we should look at, and that's where the circle is going to go, because that's the number we're comparing our variable to. And we're going to pick one to the left, or a smaller number, and one number to the right, or a bigger number than -1, and see which one of these actually works. So if I start here, -2 and -1, it's like 2 down votes versus 1 down vote, and the -1 is actually better, and that's showing the greater than side is pointing to the -1, which is greater than. So -2 is a solution, because -2 is smaller than -1. Here, -1 and -1 have the same value, and because there's an equal sign, this is a solution as well. Now 0 is not smaller than a -1, so 0 is not a solution. It's actually on the bigger side, or the right side of -1. So 0 is not a solution. Now, we know that -1 is a solution, so to show that that is a solution on the graph, we're going to fill this in. Now -2 is a solution, and everything to the left is also a solution, and everything to the right is not going to be a solution because 0 is not. So -1, -2, -4, everything to the left on the number line is going to be a solution. Even if you go out even further to -17, to -49, or a little closer at -1.5. That's still on the number line and to the left of -1. So the next inequality that we have is -4 is less than or equal to y, and y is on the right side. But it doesn't matter what side the variable is on. In the first example, we have x on the left, but we can move x on the right and 2 on the left, and the greater than sign turns into a less than sign to see that x is still bigger. We can move m and -1 to the other sides as long as we change the less than or equal to symbol to a greater than or equal to symbol. So we can move y to the left as long as we moved -4 to the right, and the less than or equal to symbols becomes a greater than or equal to. Remember to put that equal to sign underneath our symbols. Now we're comparing y to -4, so -4 is where the circle is going to go. And we are going to write in a number to the left that is smaller and a number to the right that is bigger. So we're going to compare -4 to -5 and -3 as well. So -3 is bigger than -4, so we see that as the bigger one. And we see -5 is to the left, which means -4 is bigger than -5. And we see -4 and -4 both have the same value, and that they are equal. So we know that is a solution. and negative 3 is bigger, and that's what the inequality symbol is saying. And here it's saying negative 5 is bigger, and that is not true. So we know negative 5 is not a solution, negative 4 is, and negative 3 is as well. So since negative 4 is a solution, and negative 3 is a solution, we're going to fill in that circle and point our arrow to the right, because we want all of those y's to be greater than negative 4. So all of these numbers that are underneath the arrow are solutions, and everything to the left on the graph would not be a solution. So negative 4 is a solution, negative 1, 0, 1, positive 7, positive 92, everything to the right of negative 4 on the number line, including negative 4, because the equal to sign is a solution in this case. Now 3 is greater than or equal to f. We can flip f and 3 to the opposite sides as long as we take the opposite of the greater than or equal to symbol and write the less than or equal to symbol. Now we're comparing f to 3, so we're going to be putting the circle on positive 3. Now the numbers we're filling in for f, we will fill in 3 and then 1 on either side of 3. So 2, which is smaller than 3, and a number to the right, which is bigger, or 4. So if we're looking at 3 and 2, 3 is bigger. If we're looking at 3 and 3, they are equal. And if we're looking at 3 and 4, 4 is to the right, or 4 is bigger. Now let's see if this makes sense. 3 is bigger than 2, and that is true. 3 is equal to 3, and that is true. That is a solution. And this is saying that 3 is bigger than 4, but we know 4 is actually bigger than 3. So this is not true. This is not a solution. So we see 2 is a solution, 3 is a solution, 4 is not. Which means if 3 is a solution, it's going to be filled in. And we are going to have everything to the left are going to be all of those f's or solutions that are smaller or equal to 3. So everything to the left is a solution, but everything to the right is not going to be a solution. So we see that 3 is a solution. We see that 2 is a solution. 0 is a solution. Negative 4, negative 92. Everything to the left is going to be a solution, even a negative 23. Doesn't matter what it is as long as it's to the left of a positive 3 on the number line. So now we're given a graph and we want to write two inequalities that are representative of the graph. The circle is at negative 3 and x is the arrow. So we are comparing x to negative 3, or we're comparing negative 3 to x. Now this x is on the bigger side. It's pointing to the bigger side of the number line. So x is going to be bigger. So we're going to show that x is bigger in each of these cases. And since it's an open circle, we're not going to put the equal to sign underneath that. And in this case, we have x is on the arrow, and we're comparing x to 0 or 0 to x. Now, if we're looking here, this x is pointed to the smaller side of the number line, so x is going to be smaller. And if we look at 0 and the circle, 0 is a solution, so we are going to draw the equal to sign underneath. And those are the two inequalities that represent that graph. X is on the arrow, and we're comparing x to negative 2 because negative 2 is where the circle is, or we're comparing negative 2 to x. And x, or the arrow, is pointing to the bigger side of the inequality. So we see that x is bigger than negative 2, or negative 2 is smaller than x. And since we have a solution at negative 2, we're going to write the equal sign. Here we're comparing x to 4, or comparing 4 to x, and the x, or the arrow, is pointing to the smaller side, so we are going to put the smaller side towards x, and since there's not a solution there, we're not going to put an equal sign. Which inequality is represented by the graph? So we are looking at 4, and x is where the arrow is. So we're comparing 4 and x. So we can compare x to 4, or we can compare 4 to x. Now x is pointing to the bigger side, So we're going to put the bigger side of the inequality symbol towards x. And here we are seeing 4 is bigger, x is bigger, 4 is bigger, or x is bigger. And we want x to be bigger. So A and C are out because it's saying that x is smaller than 4. Now here we have that there is not a solution at 4, so it cannot be equal to. So A and B are saying that x can be equal to 4, so A and B are not true because of those reasons. Now answer choice D is saying that x is bigger than 4, but not equal to 4. And that's one of the ways that we can write the inequality that's being graphed. So our final answer is D. And the first inequality that we wrote was the inequality that we see on choice D. So which two inequalities correctly represents this graph? So we're comparing 8 and x, or we're comparing x and 8. And x is going to be smaller than 8, and there is a solution at 8. So we're comparing x to 8 or 8 to x, and x is smaller on the smaller side of 8, so we're going to have the smaller side of the inequality, and it's going to be equal because there is a solution at 8 here. So those are two possible inequalities that are written. So when we see a closed circle, it's going to be the less than or equal to sign or the greater than or equal to symbol. So A does not have the correct symbols, and D does not have the correct symbols. B and C have the correct symbols because of this. Now we want x to be smaller than, so we see that x is smaller than in both cases in B, and here we're saying x is smaller than, but for C the second one is saying that 8 is smaller than. So C is not saying the same thing in each of those situations. So answer choice B is saying that x is smaller than 8 in both situations, and it's also saying that x can be equal to 8. So which two inequalities correctly represents the graph for question number 3? We're comparing x and negative 2. So we can compare x to negative 2, or we can compare negative 2 to x. Now there's not a solution, and this symbol is going to be using the greater than or less than symbols. So A has the wrong symbols, and answer choice C has the wrong symbols, because we can't be equal to negative 2. And if we look at x, x is pointing to the bigger side of negative 2. So x is going to be greater than negative 2, or negative 2 is going to be less than x. So here we see that negative 2 is the bigger situation, and here x is the bigger one. In D, we see that x is bigger in both situations. So D is actually saying the correct inequalities. For number 4, which graph represents y is less than negative 3? So if we look at our less than symbol, this is going to be an open circle because it cannot be equal to that. And it's going to be an open circle on negative 3. So A has an open circle on negative 3, B has an open circle on negative 3, C has a closed circle on negative 3, and that's not what we want, so C is not a good choice. 3 does not have an open circle on negative 3, so D is not a good choice either. Now, if we're looking at the inequality symbol, the smaller side is by y, so we're seeing that y is smaller than negative 3. So this y is pointing to the smaller side. Our graph of y is pointing to the bigger side. For C, our graph of y is pointing to the smaller side, and for D, our graph of y is pointing to the bigger side. And we want y to be smaller than negative 3. So the bigger side for D is not good, and the bigger side for B is not good either. And A is correct because we have an open circle on negative 3, and we see that y is pointing to all of the smaller numbers than negative 3. So A is our best choice. For question number 5, we need to circle the statement that is true. So here we're saying that 2 is bigger than 3. And if we look at 0, we're going to count out 1, 2, 3, and we see that the bigger side is on the right side, and 3 is actually bigger. So this is not a true statement. Now here we're saying we have a negative and we have a positive. So the negative 5 is going to be to the left. So we have a negative side and a positive side. So we have a positive 5 on the right and a negative 5 on the left. And the bigger side is always to the right of the number line, so we see that 5 is bigger. And here it's saying that negative 5 is bigger. So this is not a true statement either. Now here it's saying 0 is bigger than 5. So if we look at 0 and put the 5 on the positive side, a positive 5 is actually bigger than 0. So this is not saying a true statement either. This is saying that 3 is bigger than 2. And if we look at this number line, 3 is furthest to the right. So 3 is actually bigger than 2. So this is the only true inequality statement. For number 6, we're going to graph the inequality on the number line. And we're going to graph m is greater than 1. So we're going to put an empty circle on 1 because we are comparing m to 1. Now, if we look to the left of 1, we get 0, which is smaller, and to the right of 1, we have 2, which is bigger. So we're going to rewrite our inequality, and we're going to try 0, 1, and 2 for m. See if they're solutions, and see if 0, 1, or 2 are greater than 1. Now 1 is not greater than 1. 1's equal to 1. That's why, since we don't have a solution at 1, that's why we are not coloring in our circle. Now 0 is not bigger than 1. 0 is to the left, or the smaller side of 1. So this is not a solution. So 0 does not have a solution. Now 2 is bigger than 1. Well, 2 is on the bigger side of 1. So we see that 2 is actually bigger than 1, and this is a solution. So we know our arrow is going to go towards the right. Now we could see that m is on the bigger side, so we see that our arrow is pointing to the big side, and our greater than symbol is going to have an empty circle on 1. Number 5 on the next page wants you to graph the inequality on the number line. So a is less than or equal to 4, and if we look at this inequality symbol, it's the less than or equal to symbol. So the circle, because of the equal to sign, is going to be shaded in, and it's going to be shaded in on 4. So we are going to put the closed circle, or the shaded in circle, on 4. Now, it's saying that a is less than or smaller than 4. So we want all of the a's to be smaller than 4. If we look to the left of the number line, this is where numbers get smaller, and to the right of the number, that's where the numbers get bigger. So we want the smaller side, so we're going to point that arrow towards the smaller side, or the left side. You could have also thought of this by testing different values. So if a is less than or equal to 4, we could have chosen 3, 4, and 5 on one number on either side of 4 and 4 itself. So we're going to put 3, 4, and 5 in for a and compare 3, 4, and 5 to 4. Now, if you're comparing 3 and 4, 4 is bigger than 3 because it's to the left. 4 is to the right of 3. Now 4 and 4 are equal, and 5 is bigger than 4. So here it's saying that 4 is bigger, so that's a true statement. Here it's saying that 4 can be equal to, and that's true. Here 5 is saying that it's smaller than 4, and that is not true. So if we're looking at these solutions, 3 is a solution because 3 is smaller than or equal to 4. 4 is equal to 4, so that's a solution. And 5 is not equal to or less than 4. So everything to the left where the line is the solution. Everything to the right is not. So for number 6, it's asking which inequality is graphed below. Well, if we look at x is less than or equal to -1, this less than or equal to sign is going to put a circle, and the equal to sign is going to make it closed circle on -1. This greater than symbol is going to make a circle on -1, and it's not going to be equal to, so it's going to be a open circle or an open circle. This less than symbol is going to put a circle on -1, and there is no equal to sign, so we're not going to color it in. This greater than or equal to symbol is going to put a circle on -1, and it can be equal, so we are going to color in that circle. It is a closed circle on -1. So we have an open circle, and we see that A and D have the wrong kind of symbol for an open circle. So C and B are still in the running. Now we see that A is telling me that x is smaller than -1. Here B is telling me that x is bigger than -1. In C, we are being told that x is smaller than -1. And in D, we're being told that x is bigger than -1. So if we look at the number line, the smaller side of the number line is to the left, and the bigger part of the number line is to the right. And x is pointing to the small side, or the arrow is pointing to the small side. So A and C are pointing to the small side, and D is pointing to the big side, and B is pointing to the big side. So those are not good choices. C is the only one that has the open circle and x pointing to the smaller side. Number 7 asks you to put a check mark in all of the boxes below, or these boxes, that include the number 4 in their solution. So we're looking at the number 4 on the graph. So here we have 4 is hitting the arrow of the graph, and that's part of the actual graph. So this is a solution. Now 4 here is hitting some empty space, so it's not really part of the graph. So 4 is not part of the solution. So this is not an answer. In this example, we have 4 is hitting the closed circle, or a closed circle part of the graph. A closed circle is a place where there is a solution. And in this last example, 4 is hitting an empty circle. So this is not going to be a solution. So if you're hitting the arrow or a closed circle, it's a solution, but empty space or empty circle, it is not a solution. Number 8 asks you to put a check mark in all of the boxes below that include the number 4 in their solution. So here we want to know if 4 can be a solution for x. So we're going to replace x with 4 in this inequality and see if it makes sense. Now, is 4 less than 4? No. 4 is actually equal to 4. So 4 is equal to 4. 4 is not less than 4. So this is not a solution. For this one, let's see if 4 is a replacement for x. And here we're saying that 2 is greater than 4. But if we look at the number line, we'll count 0, 1, 2, 3, 4. And 4 is furthest to the right, so we know that 4 is bigger than 2. And that's not what this inequality is saying. So that is not true, which means that is not a solution. Now 4 is greater than or equal to 4. Let's see if 4 is a replacement value for x. Now we know that 4 is equal to 4, and that's what this symbol is asking. So yes, 4 is a solution for this third inequality. Now if we can replace x with 4 in this last one, then we could see if -2 is less than or equal to 4, and see if 4 is the solution. So on the number line, we've got 0, we've got 1, 2, 3, 4 on the positive side, and -1, -2 on the negative side, and 4 is furthest to the right, so we know that 4 is bigger than -2, And that's what this inequality symbol is saying, so we know that this is true, and this is a solution for the last inequality. Your note should now be 100% complete. All work should be shown in your notes. Any questions that you have should be written down and handed in.